In this presentation, I will be talking about instruction set of 8085 and the different classifications of those particular instructions. My name is Microprocessor. I'm from the computer science department. So, as already mentioned, in this we'll be talking about the instruction set of 8085 and the different classifications. Some of the classifications we'll be discussing are data transfer, arithmetic, logical, branching, and control instructions. So let's start with what exactly is the data transfer instructions. Actually, these instructions move the data between the registers or between the memory and registers. Important thing is that the data is not actually altered when you copy the data from source to destination. So let's start with the first instruction, that is MOV. Operands are RDRS, where R is the register, D is the destination. So R suffix D is destination register and RS is the source register, where mem is the memory and RS is the register source, RD is the destination register and M is the memory location. So what will happen in this first set of the operands, the data will be copied from RS, that is source register, to the destination register, where the source register's contents are not altered altogether. So let's take an example. So example is MOV B comma C. So C is the source, B is the destination. So data from C register will be copied to source B. And in the second example, you can see that it is MOV B comma M. So M is the memory location. And so whatever the M has, it will be copied to B. Now the next instruction is MVI. MVI operands are RD data and M data. So RD means destination register and D means the 8-bit immediate data. So whatever data is 8-bit data is, that will be directly copied into the register. And same happens in the memory, M data. So M is memory, so data will be copied, immediate data will be copied to the D. And the example is NVIB, 57H, where 57 is the immediate data that will be copied into the register B. Or if you could see this particular example, where 57 is the immediate data that will be copied into M. Important thing in this particular example is that which particular memory location it is actually pointing to. So this M is actually pointing to the content of the HL register. So HL register will have the address, and whatever HL has the address, whatever address HL has, the M will be pointing to the content of that particular HL register. Coming to LDA. So LDA has an operand 16-bit address. So what will happen is that the contents of the memory location specified by 16-bit address will be copied to the accumulator directly. So as you could see that A is the L load, LD is load and A is accumulator. So 2034, whatever data is there at 2034 location, that will be copied in the register A. Next is LDAX, and this LDAX will actually has an operand like BC or DE pair. In Microprocessor 8085, the only combinations of the registers are BC, DE, or HL. So BC pair or DE pair works with LDAX. So whatever address this BC or DE has, the data of them will be copied into accumulator A. Example is this LDAX B. So whatever the BC would contain, the address that would contain, so contents of that address would be copied to A register. And this is LXI. So LXI is load the register pair, HL pair, okay, with the immediate address or 16-bit data. So what will happen in this is that it will load 16-bit data into the register pair HL. As you could see, go ahead. Thank you.